Welcome back, and in this video we are going to discuss few basic list operations. So let us start with some of the examples. So first of all, I'm going to tell you about the slicing. So I have just kept some piece of code with me so that it will become easy while I'm describing it to you. So let me show you first the slicing. Okay, so this one is a list L which contains these elements 12, 34, 56, 78, and 89. And I want to slice this. Slicing means I want to slice few of the items. Like I want to start from 12 and I want to print till only 56. Or I want to start from 56 and I want to print only till 78. Then what I will do? So in that case, you can use this operator, this colon you can see. You can see this print statement, and here I have written the name of the list, which is L, and I have started it from 2, location 2, which is 0, 1, 2. So it will start from 56 and it will end at 3 because this 4 is not exactly 4. Like if you see 0, 1, 2, 3, 4, it should be 89. But when you are slicing, then the second thing after this colon is the n minus 1. It's not the end. Fourth is not the end. This is basically you need to go till n minus 1, which will be at 3, at location third, at index 3. Okay, so it will print 0, 1, 2 from second till 3. So 2, 3, 2, 4 means it will start printing from 2 and it will end till 4. Okay, so this is how it slices the things. So let me show you the example by running it. Okay, so you can see 56 and 78. Okay, so if I want it from like, if I don't give the beginning, right, before the colon, I don't give anything, then what will happen? Let us see. So this will be like starting from beginning, not giving nothing before this colon means start from beginning, and from beginning reach till location 3, which is index 3. So 0, 1, 2, 3. So it has started from 12 and it reaches till 78. Okay, and similarly, if I start from 2 and I don't give anything after the colon, then it means that start from 2, 0, 1, 2, start from 56 and reach till the end. Okay, so what will happen now? The output should be 56, 78, and 89. So I hope you might have understood the concept of slicing, right? So this was all about the slicing, and don't worry, I will provide all this code to you so that you can run it on yourself and understand. I'm just explaining it to you here. Okay, so let me go to the next one, which is mutability. What is the mutability? Let us first understand that, and then we will see this example. Mutability means you can change anything in the list. Once you have created the list, if you are allowed to make any changes in any of the data structure, then that data structure is known as a mutable data structure. Like list, after creating this list, I can update any of the element at particular index. Okay, I can add anything in this list. I can subtract anything from this list. So any such list, any such data structure which can be mutated, which can be modified after its creation, that kind of data structure is known as the mutable data structure. Okay, so now if you see it here, L2, I'm assigning L2 as 90. So 0, 1, 2. So in place of 30, it should be printing 90. So if I print it like here only, then it should give me, you can see if I'm printing L, then it is printing 10, 20, 90. Okay, here it is printing 90 because at the second index I have copied 90 now. Okay, I have placed 90 now. So it will give like 10, 20, 90, 40, and 50. Okay, so this print L will work like this for the, if you update any value at any particular index. And at the same time, you can give a range. Okay, I want to give the range like from 1 to 3, 10, 20, 30, right? From starting from 1. So starting from 20, I want to give like till 3, right? After that, 3 positions, okay? 1, 2, 3. Starting from 1 till 3 positions, I want to update it with 2, 3, 4. So it will become 2, 3, 4. Starting from here, 20 will become 2, this will become 3, and this should become 4. Let us see the output. So if I run it, here you go. You can see 2, 3, 4. These have been updated in the second print statement, okay? So now you might have understood that how you can mutate any of the list within a range. Okay, so this was the basic example about the mutability. You can do the exercises by your own. Okay, you can remove this particular index, sorry, this particular thing before the colon, basically the start index, and also you can remove this one and do the experiments and see what happens. Okay, so this was about mutability. Now let us see something about the concatenation. What is concatenation? Concatenation means adding two of the lists and creating another list. Okay, not adding two lists, basically at the end of the list appending something new. That is the concatenation. So in simple words, it's the appending at the end of any list. So appending at the end of any list is known as the concatenation. So here you see we have the list L1 which contains 1, 2 and 3, and then I'm doing like L1 is equal to L1, and at the end of L1 I want to add 5 and 6. So if I will print L1 now, then it will give me 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 5, 6. Okay. So let us see 1, 2, 3, 5, 6. So this is called the concatenation. Okay. Now let us see the other example, which is merging. Okay, merging is different than the concatenation. Merging means adding two lists, L1 and L2, and creating a new list from the contents of L1 and L2. If we do this kind of thing where we are adding two of the strings to create a new string, then that operation in the list on the list is known as the merging of the list. So if you see here, if you add L1 plus L2, then it will obviously give 1, 3, 4, 6, 10, 30, 40, and 60 for the L3. Okay, because L3 has been concatenated, sorry, merged by the L1 and L2. L1 and L2 both have been merged into L3. So this is the output of L3. Okay. So now let us see the other example of conversion. Okay, so if you want to convert anything into the list, suppose I have this string which contains Vikas and I want to convert it into the list. It's a string right now. I want to convert it into the list. Then what will happen that this list function will break each of the characters in this string into the separate elements in a list. Okay, so V will be an element in the list, I will be the second element in the list, and K will be the third, A will be the fourth, and then fifth and the sixth element of the list. You will be able to see them. So let me run it, and here you can see all the elements which are the characters, they have become the separate elements of this list. Okay, so print L1 has printed that. Those characters have been printed now. Apart from that, let us see if we have any value. V is equal, suppose n is equal to 10. This is an integer. Let us see if what will happen if I do the same thing with the integer. Okay, so let me see. Okay, so S, this cannot be, you know, converted. Why it cannot be converted? Because this is not iterable. Anything which can be iterated, like in case of a string, you can iterate it. You can iterate through the elements. You can move from one to other. Wherever the indexing and wherever the movement from one location to the other location within the data structure is allowed, only those can be converted using the list. Okay, so this is the concept. Like list, anything which is like a string or which is like tuple or which is any kind of data structure which can be converted, which can be iterated, which can be which is iterable, basically, in which you can iterate through a for loop each of the element. In that case only it will work. Okay, the conversion will work. So it will not work for the your integer. It will not even work for the character as well. If I run it, then also it should not work. No, it is working because it's taking it as a string. Okay, because if we are thinking it as a character, then it's not a character, it's a string which contains only one character, which is a, and that is why it has been converted here. But normal integers, floats, all those things, they cannot be converted because they are not iterable. Any iterable data structure only can be converted into the list using this list function. So this was about the conversion. Now let us see how we can search within, and if we want to search something, then what we can do. Suppose this is a list L1, this contains 2, 3, 4 and 5, and we want to search whether the 5 is in the list or not. We want to check whether 5 is in the list L1 or not. So since 5 is in this list, so 5 in L1, this will return true because 5 is in L1. If you see 5 is the element in the L1, so that is why it will give me true. Okay. Now if I come to the next statement, 14 not in L1, then again it is true because 14, there is no such element which is 14 in this L1, so this will give me true again. Okay, but if I do like 14 in L1, then what will happen? It will give me false because 14 is not in L1. Now let us come to checking the emptiness. If you have to check whether a list is empty or not, then what you will do? Suppose this L1 is not an empty list. It contains some values, but L2 is empty. So in that case, you just need to use the not operator. Okay. So if L1 is empty, then if you use not, then it will return true. Otherwise, it will return false. You can see that L1 contains some elements. So using not will return false because L1 containing some element, it's not empty. So not L1 will only return true if the list is empty, but this list is not empty here. So if you run it, then the first statement will return false because L1 is not empty, but L2 is empty. So not L2 is returning true. So that is how the emptiness can be checked. So these are the basic operations that you can perform, that you can check using certain functions, certain operators like in, not operators. All these we discussed for emptiness and the searching. So all these things you can check your own. Okay. So I will provide this content to you in the resources section. So please check that. So with this, this particular lecture comes to an end, and I hope you might have enjoyed it. You might have learned something new. So in the next video, we will see some new topic related to the list. Till then, have a nice day and bye-bye.